Okay, we have here today another integral from MIT 2020, problem 14. Okay, we have a big messy integral here and we got a couple of series. This is something that MIT does a lot. I think they made this problem, it looks really hard with the series, and then when you get into it, it's actually not too bad. So my first step, I'm going to do something really straightforward and consider this like two integrals, and we'll just integrate this because we know how to do this one. This is going to be natural log of x minus 1, and so we get that out of the way. And then what I'm going to do is I'm going to rewrite this. I mean, we could deal with it as a series, but I think it's easier. Maybe it's just easier for me to explain. Maybe I'm just kind of like selfishly want to explain it how I can explain it. What I'm going to do is instead of leaving it as a series, I'm just going to kind of plug in the numbers and like kind of see where it's going. So like if I look at 0 for our first term, if I plug in 0 here, we have 1 times x to the 0. That's just a 1, okay? So looking at a second term, when k equals 1, we're going to have 2 times x to the 1, okay, just 2x. One more term, okay, k equals 2. We end up with 3x2, so we get 3x squared. And not to bore you guys, because this is just going to go on, but we'll do the last term. When we get all the way to 2018, we plug 2018 in here, we're going to have 2019 times x to the 2018. Okay, and then same thing in our denominator, just a little simpler. We plug a 0 in here, we get a 1. Plug in a 1, we get an x squared, and then our last term is going to be x to the 2019. And then now maybe you see it, and what we can do is, let's do a u substitution. And what I'm going to do, I'm not going to rewrite it, but I'm going to call this whole denominator u, and then notice, if you take the derivative of that, this is going to be the derivative, so we're just going to have du in the numerator. Just noticing like derivative 1, 0, derivative of x is 1, derivative of x squared is 2x. Derivative of this last term, x to the 2019, is 2019, x 2018. So it's set up perfectly. So then just doing this integral will bring down this first piece. We're going to have natural log x minus 1. And then here we're just going to have natural log of u, but I'm just going to substitute it right away. I'm just going to reverse the order here. So we're going to have x 2019 plus x 2018 all the way to x plus 1, okay? And then technically we can be done right now, but I think what I want to do is, let's use the property of logarithms, okay? We have a plus sign here, so we can actually multiply this together. So we can multiply this times this. And for that, I'm going to use a formula, and let me just show that real quick. Okay, so hopefully this is familiar. You have this formula on the board, and you'll notice, like whatever our n is, right? If we have like x to the 8th minus 1, x to the 2020 minus 1, whatever it is, you'll notice that 1 is always going to be a factor in this. If you put 1 in here, that 1's going to be a 0 of this. That means you could factor out an x minus 1 from this. And if you do it, you just get like this sequence of all the terms, and that's exactly what we have here. So we have our x minus 1 here, and then we have, like this will be our x to the n minus 1, n minus 2, all the way to 1. So when we put these together with our natural log, okay, this whole thing is actually going to be x to the, if 2019 is our n minus 1, our n is 2020, so we're going to have x to the 2020 minus 1 plus c. And that's it. That'll be our final solution right there. So like I said, I think it's a fun problem, but it's actually pretty easy. We did it in just a couple steps, so not too bad. We'll stop it there. Thanks for watching. Please like and subscribe. Have a great day.